Okay, folks, hello. Let's see if I can do the differentiation and integration, just the basics. Okay, really, this is not the whole thing. There's loads more to it, but this is just the basics, and I'm going to try and do it in less than 7 minutes. Okay, so differentiation first. If you've got the examples like y equals 5x cubed, you know that when you differentiate that, you change the left-hand side to dy by dx, and you do 3 times 5, and then you take 1 from the power. Now, if the question looks like f of x equals instead of yx, instead of y, then you might have 7x to the power of in fact, let's do a slightly weirder one. Let's do the square root of x. Okay, now you cannot differentiate it when it looks like that, so we have to rewrite the question, and you should know by now that the square root of x is the same as x to the power of a half. Now we're ready to differentiate, so now we change the left-hand side to f dash of x, and we do the same over here when we did 3 times 5, and then we took 1 from the power. We do the same here, so we do x times an invisible, half times an invisible 1, and then we take 1 from the power. Half take away 1 is negative a half. Now, you would be expected to rewrite that answer for higher maths. You'd be expected to write the power as positive. So if we put the x downstairs, it's going to meet with the 2, and it will be power positive a half. You would then also be expected to change that to power of a half back into square root of x. So that's a more challenging version of the same thing. But basically, it's wee number times big number, and then take 1 from the wee number. Okay, so that's one type of differentiation. The other type of differentiation that you'll be seeing lots of is things like 4 cos x. And you need to know that when you differentiate that, dy by dx, you need to know that cos becomes negative sign. So 4 cos x will become negative 4 sine x, okay? And you can look that in your formula sheet to be sure, okay? And equally, if you've got f of x equals 5 sine x, so 5 sine x, when you differentiate that, you need to know that sine x, when you differentiate it, stays the same sign, and it becomes cos. So that will just become 5 cos x. So when you're differentiating cos, it becomes negative sine. When you're differentiating sine, it becomes cos. But you can check which one's negative and which one's not from your formula sheet. Okay, so that's your basic differentiation. Now, underneath, what I'm going to do is the chain rule for differentiation. And what we've got here is, say, for example, the question is 5 times 2x plus 1 cubed. Now, if you compare that question there to the original question that we had up here, 5x cubed, the first stage of this works the same way. So I want you to pretend that that bracket is an x. So if the question was 5x cubed, the answer would be, it would be 15x squared. So if that bracket was an x, that would be the answer. But then you say to yourself, it's not an x, it's a pretend x. So now what you have to do is multiply by the derivative of the pretend x. And the derivative of 2x becomes 2, and remember, when we differentiate numbers, they disappear. So the derivative of 2x plus 1 is just 2. So our final answer would be 30 times 2x plus 1 squared. Let me do another example of that. Say the question was 5x, and you had the square root, I'm keeping it the same as the ones on top deliberately, of 3 minus x. Then the derivative of that, we're not ready for that. I shouldn't do that yet. We need to change the way the question looks, and we need to rewrite it as 3 minus x to the power of a half. Okay, now we're ready to differentiate. So we do a half times invisible 1, x, take 1 from the power. So if that bracket was an x, that would be the answer, but it's not, so we multiply by the derivative of our pretend x. And the derivative of 3 minus x, well, 3 disappears and minus x is minus 1x. So the derivative of that would be minus 1, which turns the whole thing negative. And then we would just have to tidy that up. So it would be negative, and then there would be a 2 in the bottom, and then we would have 3 minus x, and it would be the square root of that, and then we would have a 1 on the top, and that would be us. So let me just do another few of them before we do the next thing. So say the question was 3 times 9x plus 1 to the power of 7. So pretend the question says 3x to the power of 7. If it did, the answer would be 21x to the power of 6. But then we multiply by the derivative of our pretend x. The derivative of 9x plus 1 is 9. And I have no idea what 21 times 9 is. What would that be? Oh man, 210, that's times 10. Take away a 21. Oh man, this is a bit much for me on a Saturday morning. So 189, here we go. Shouldn't have chosen such big numbers. Okay. And if we look at the sine and cos sine stuff, it's the same idea. Okay, so this time, instead of having 4 cos x, let's have 4 cos 2x plus 5. Okay, so we say to ourselves, 4 cos x becomes negative 4 sine x. But it's not an x, so then we multiply by the derivative of our pretend x, and the derivative of 2x plus 5 is 2, giving me negative 8 sine 2x plus 5. Now, be really clear here. Remember, when you're doing the rule on the left, okay, this type of stuff, you're taking 1 from the power, whereas when you're doing sine and cos, it's a completely different style of thing. You're not taking anything from any power, so don't be tempted to do that. You just know that cos becomes negative sine and sine becomes cos. And if we did y equals, what did we have? 5 sine, but instead of x, let's have, I'll keep doing 2's, 3x minus 1. So 5 sine x becomes 5 cos x, but it's not an x, so we multiply by the derivative, which is a 3. So that becomes 15 cos x. Now, I've been really clear to say it's the derivative that we're multiplying by, and up until now, every single one of these examples, the derivative has been a number. But what happens if it's not? It's the same logic, okay? Can I extend that line? Nah. Okay, just imagine there's a left and a right. In fact, I'll just do it. So what if the question was 3 times 2x to the power of 4 plus 1 to the power of, what we'll have, 5. So same logic, the derivative is 5 times 3, so 15x to the power of 4. So part 1 is always just pretending it's an x, but it's not an x, so now we multiply by the derivative of our pretend x. The derivative of 2x to the power of 4 is 8x cubed, and the derivative of 1 is 0. So our final answer is 15 times 8, which is 120, x cubed times 2x to the power of 4 plus 1 to the power of 4. Another one of them. What about if we had, we'll do an f of x this time, f of x being 2 times x cubed plus 2x to the power of 2. So f dash of x would be, pretend the question is 2x squared. If it was, the answer would be 4. In fact, can I actually just not make that? I'm not going to make that the b square. I'm going to make it a different number. Just because I'm oversimplifying it. So let's make it a cube. Okay, so 2x cubed would become 6x squared, but it's not an x. So now I'm going to multiply by the derivative of my pretend x. Now the derivative of x cubed is 3x squared, and the derivative of 2x is 2. And because we've got to be careful of BODMAS here, so we need to make sure we put it in brackets, so as we're multiplying by the entire derivative. And you can change the order of that if you want, but it wouldn't actually make any difference. So how does that apply to sin and cos? Okay, let's have a think. So y equals 3 cos 2x squared. Don't like squared, don't like 22s, 2x to the power of 4. So dy by dx is, so 3 cos x becomes negative 3 sin x, but it's not an x, so then we multiply by the derivative of our pretend x. The derivative of 2x to the power of 4 is 8x cubed. So that would be minus 24x cubed sine 2x to the power of 4. And then you can get kind of weird ones with that, where you've got, what about if you've got, what is the derivative of cos squared x? So you know that cos squared x means cos x all squared. So when you're differentiating this, your pretend x this time is the cos x. So you're pretending your question says x squared. If it did, the answer would be 2x. Oh, I don't like that bracket. 2x to the power of an invisible 1. But it's not an x, so then we multiply by the derivative of our fake x, and the derivative of cos x is negative sin x. So the answer to that would be negative 2 cos x sin x. So just try to think of the pretend x, okay, for these styles of questions. Oh, let's do integration quickly. The good news is it's a bit quicker. So for integration, I'm going to keep the examples really similar. So our basic integration, we don't write like that, obviously. We write an integration question like that. Okay, and remember the integral symbol and the dx in your question is always sandwiched in between. And what these things on the left and right mean is please integrate the thing in the middle, okay? And so when you begin to integrate, they disappear. So when we integrate, you add 1 to the power and you divide by that number and you put your c. I am making this video for people who have seen a bit of integration and differentiation before and just need it pulled together. If this is the first time you've seen it, you probably need to take it more slowly. So, and then you would simplify if you can. So let's do another one of them. What about if you've got 2x cubed dx? So the answer would be add 1 to the power, divide by that number, plus c, and that simplifies to x to the power of 4 over 2 plus c. Okay, and what about your sin and cos? Please integrate 3 cos x dx. So remember, when you differentiate cos, it became negative sign. When you integrate cos, it stays positive, but you can look that up on your formula sheet. So the answer is 3 sin x plus c. And what about 4 sin x dx? When we integrate sin x, we do get negative cos. So it becomes negative 4 cos x plus c. Okay, so that's your basic sin and cos. What do we do when it's a pretend x? So when you're integrating, let's do the left-hand side first, actually, sorry. Basic integration done, let's do 3 times 2x plus 1 to the power of 5 dx. Okay, so again, we're going to pretend the question is 3x to the power of 5. Now, we did that earlier up here. No, we didn't. We did 5x cubed. Oh, never mind. So we add 1 to the power and divide by that number. So pretending the question is 3x to the power of 5, the answer will be 3x to the power of add 1 to the power and divide by that number. but it's not an x. And so remember when we were differentiating, we multiplied by the derivative of the pretend x. This time we will divide by the derivative of the pretend x. So it's still the derivative, so it's still that 2. So we're dividing by that 2. So we put it underneath like that, plus c. So when you're differentiating, you multiply by the 2, and when you're integrating, you divide by the 2. And the good news with integrating is you will not be asked in higher maths to do 2x to the power of anything. The derivative for integrating examples will always be a number, okay? In higher. Obviously, there is a way of doing that, but it's just not in the course. So that will be 3 divided by 12, which is the same as a quarter. So 2x plus 1 to the power of 6 divided by 4 plus c. Let's do more of that. So integrating what we have, 5 times 2 minus 3x to the power of 2 dx. So pretending the question is 5x squared, the answer would be 5x, add 1 to the power, divide by that number. But it's not an x, so we also divide, which means put on the bottom, by the derivative of our fake x. And the derivative of 2 minus 3x is minus 3. Remember, the 2 disappears and minus 3x becomes minus 3. So that will become negative 5 over 9 times 2 minus 3x. We can either put that like that, or we could put the whole line across. It doesn't matter, as long as it's on the top. Oh, plus c. Oh. Sin and cos examples, and we're done. What about if you've got 3 cos 5x minus 9 dx? Okay, so 3 cos x, we're pretending it says 3 cos x. If it was 3 cos x, the answer would be 3 sin x. But it's not an x, so we divide by the derivative, which is 5. What about if you've got 2 sin 2 pi x minus 1 dx? So 2 sin x, pretend the question says 2 sin x. If it did, the answer would be minus 2 sin x. But it's not an x, so we divide by the derivative of our pretend x. And the derivative of 2 pi x is 2 pi, and the derivative of minus 1 is just 0. So that would be our answer. And strictly speaking, your 2's can cancel, giving you x minus 1 over pi plus c. Okay, folks, so I don't think that was 7 minutes, but you've got to admit that was pretty fast. And I'm really hoping that helps, folks. Okay.